of a radioactive element with a half-life of 2 minutes has an initial mass of 800 grams. Plot a graph to illustrate its disintegration. Show the data for the graph in the table and use the graph to find the time at which the mass of the sample is 30 grams. Solution. Looking at the decreasing value in grams table and the time in minutes table. When the mass is 800, the time is 0. When the 800 is equal to 400, the time is 2. When the 400 is equal to 200, the time is 4. When the 200 is equal to 100, the time is 6. When the 100 is equal to 50, the time is 8. When the 50 is equal to 25, the time is 10. Figure 5.3 illustrate the mass in gram, time in minutes graph. The time at which the mass of sample is 30 grams is equal to 9.3 minutes from the graph, when traced from the graph. Example 5. A physicist uses a radioactive source with a half-life of 4 hours as a clock. If the source initially emits 1,440 particles per minute, what interval of time has elapsed when the record 180 counts per minute? Solution. Original particle NO is equal to 1,440. 1,440 will not get anything at 0 hour. When half of 1,440 will decay in 4 hours, and half of 440 is 720. Then 720 will decay in 8 hours, and half of 720 is 360. Half of 360 will decay in 16 hours, and half of 360 is 1/8. The time elapsed after 180 counts per minute is equal to 16 hours. Example 6. Calculate the half-life of radioactive isotope who has a decay constant of 0.000456 per day. Solution. Half of T is equal to 0.683 all over lambda, which is equal to lambda is equal to 0.000456 per day. Therefore, capital T half is equal to 0.683 over 0.000456 per day, which will give us 1,520 days approximately. Example 6. The original quantity of a radioisotope is given at 100 millicuries. If the quantity remaining after 6 days is 75 millicuries, calculate the decay constant P half-life of radioisotope. Solution. A. NO is equal to 100 millicuries, MCI. N is equal to 75 millicurie, and T is equal to 6 days. From the equation, lambda is equal to 2.303 log N over NO over N all over T, which is equal to 2.303 log A over 6 times log 100 over 75, which will give us 2.303 over 6 times 0.1249. That is equals to 0.3838 times 0.1245 days per days, which is now equals to 0.04795 per days. But B, use T half equal to 0.693 all over lambda. T or half-life capital T half is equals to 0.693 all over 0.04795 per days, which gave us 14.5 per days. Example 7. A sample of radioactive material has a half-life of 15 hours. How much of the original radioactive nuclei will remain after 45 hours? Solution. 45 constitutes 3 half-lives. Half of 15 will give us 45 divided by 3 will give us 15. Then 2 times 15 will give us 30. Then the half of 30 is times half will give us 30. Then half of 30 times quarter of 30 will give us 45. Hence, the nucleus remains 1 over 8. Energy quantization. Concept of energy quantization. Energy of electron consists of small units or discrete packets called quanta of amounts, hV, where V is the frequency of radiation and H is a constant known as Planck constant. Thus, kinetic energy of electron is equal to hV. Energy level in atoms. An atom exists in one of set of well-defined energy level. To excite an atom from first energy level ground state to second energy level, required amount of energy given by E2 minus E1 equals to EV, where EV is electron volt. Note: the ground state is the stable state of an atom corresponding to its minimum energy. 1 electron volt, 1 EV is the energy acquired by an electron in falling freely through a potential difference of 1 volt. 1.6 times 10 raised to the power minus 9 joule. During the excitation from lower energy level to higher energy level, the potential energy is converted into kinetic energy. So the electrons eventually acquire a velocity given by Ke equals to half mv squared, which is equals to EV. Note: the energy gained by electron is equals to charge times potential difference, which is equals to EV. 2. Frequency of radiation is equals to velocity of light over wavelength. Example 1. An electron moves in a vacuum between two electrodes having a potential difference of 3000 volts. Calculate the velocity acquired by the electron if the ratio of its charge to mass is 1.8 times 10 raised to the power 11 coulomb per kilogram. Solution. Energy gained by electron equals to charge times potential difference, which equals EV. Kinetic energy is equals to half mv squared, which is equals to EV. V is equals to square root of 2 EV over m. But potential difference is equals to 3000 volts, and E over m is equals to 1.8 times 10 raised to the power 11 coulomb per kilogram. Substituting the values, we now have V to be equal to square root of, in bracket, 2 times 1.8 times 10 raised to the power 11 times 3000, which is equal to 3.3 times 10 raised to the power 7 meters per second. Example 2. An electron of charge 1.6 times 10 raised to the power 10 coulomb is accelerated in a vacuum from rest at 0